Hello geographers, and welcome to this lesson today about coastal landforms on the Dorset coastline. I live in Dorset, so I feel really blessed to be able to get out and see those stunning landforms whenever I want. I was once tricked into a Jurassic Coast marathon along the coastline by my friend, and I can tell you now, some of that landscape is incredibly hilly. Very beautiful though, so you couldn't really complain. For today's lesson, you're going to need a pen and paper. In a second, I'm going to ask you to pause and go and get those, clear away all those distractions, and then we'll be ready to learn. So get what you need. I'll see you in a second. Excellent. So get the title down at the top of your line paper for me, please. Landforms on a UK coastline, Dorset coast. Make sure you get those capital letters in the right place, please, for the county name and the country name. Let's get started and have a look what the beautiful Dorset coastline has got in store for us. Dorset is located on the south coast. It's the county in red on the map. It's located between Devon and Hampshire, and it's on the English Channel. Let's have a look at this geology map of the Dorset coast. So geology is the rock type, and we can see that Dorset has a range of different rocks. In orange, we have mudstone. Around Poole and Bournemouth, we've got a large area of clay. Then we've got some hard rocks. So limestone and chalk in purple and green are resistant to erosion. Finally, we have clay and sandstone in yellow. Dorset has examples of both discordant and concordant coastlines. A discordant coastline, as we can see in the area around Swanage, is where the rock types lie perpendicular to the sea. There is also an example of a concordant coastline, and here the rock layers run parallel to the shore. So if we look at those, discordant, the rock types lie perpendicular, concordant, the rock types lie parallel. We've looked at the geology, but let's see if we can work out where some of the places we're going to look at today are located. We're going to be mentioning today Chesil Beach, and particularly the Fleet, which is the area of water behind. We're going to look at Durdle Door, Loworth Cove, Kimmeridge, Peveril Point, Swanage Bay, the Foreland and Old Harry Rocks, Studland, and Sandbank. So we're going to travel a long distance today around this coastline. Your turn. Swanage Bay has formed on which type of coastline? Concordant or discordant? Place your votes now. 3, 2, 1. Yes, discordant. So here the rock type is perpendicular to the sea, discordant. Another one for you. So which rock type is less resistant to erosion? Write down your answer. 3, 2, 1. So hopefully you've made your decisions, and I'm hoping you answered clay. If we go back to a snippet of that geology map, we can see that clay on this map is in pink. The pink rock has eroded back, it's retreated back because it is less resistant. Limestone in purple on the map and chalk in green on the map are sticking out. They've formed headlands because they are more resistant to erosion. First of all, we're going to focus on the Dorset coast erosional landforms. To recap on what erosion is, it is the wearing away and removal of material by a moving force. And in our example with coasts, we're talking about waves. If you can't remember that, just pause the video now and get that jotted down for me, please. Let's meet our first landform. So we've got on the screen a wave-cut platform at Kimmeridge. You can see the steep cliffs at the back, but in the front of the picture, there is a wide, flat, rocky area. That's the wave-cut platform. When we have a look at it on the map, you can see that it is shown by the white wiggly lines running around the coast. Here they are. So this is the wave cut platform all the way around the outside of Kimmeridge Bay. Next we have our arch, and it's Durdle Door. I'm pretty sure every single person has seen a photo of this iconic arch. It's absolutely stunning. Named Durdle Door because of the hole that goes through, so the doorway through the rock. If we have a look at Durdle Door on this OS map, you can see that's the shape of it here. And what's really interesting is you can see over the Manor Wall Beach, there are also additional stacks running all the way across here. And the reason for it is that this was once a layer of limestone. Behind the limestone, so where these bays are, was much softer rock that has retreated. So this Durdle Door is left there in the harder limestone. Now we've got our stack, and this stack here is called Old Harry. He's formed off the Foreland headland and is made out of chalk. Around the base of Old Harry, you can see that there are also wave-cut platforms. Headlands and bays. This photo shows two headlands. The headland closest to us is called Peveril Point, and the headland in the background is called Ballard Point. In the centre of these two headlands is Swanage Bay. And remember, Swanage Bay has formed on that clay and sandstone rock, which is why it's retreated. Peveril Point is made out of limestone, and Ballard Point in the background is made out of chalk. Time to test your knowledge. Which of these was our example of an arch? 5 seconds to make your decision. And it is Durdle Door. Well done for getting that one right. Which is our example of a headland? Tricky one. 3, 2, 1. It is Peveril Point. And bonus marks now if you can tell me what the other one is. Tell me. Ballard Point. So Swanage Bay is between Peveril Point and Ballard Point. Name this famous landform. Yes, well done. So this is Old Harry Rocks. We've done the erosional landforms, so now let's have a look and see what the depositional landforms have got in store for us. Let's make sure we're clear about what deposition is. So deposition is when material being transported by the sea is dropped due to a loss in energy. If you don't know this definition, please pause now and just take a few seconds to get that copied down. Swanage Beach is our next stop. It would be amazing if we were sat on that beach right now, wouldn't it? Look at them how we're having fun. Swanage Beach is formed in a bay. It was protected by which points? Can you remember? Ballard Point and Peveril Point. So because it's in a bay, it was sheltered, and therefore those constructive waves have built this wide sandy beach. Sand dunes at Studland. All the way along Studland, at the back of the beach, we've got sand dunes forming. Sandbanks is just one of the examples of a spit on the Dorset coastline. Here, unfortunately, the spit is so long. Here's the change in direction of the coastline that's so important, and longshore drift has transported this sediment all the way along here, and then it bends round, so a really long spit. Chesil Beach is our example of a bar. Chesil Beach has stretched from Abbotsbury in the northwest corner of that map all the way down along the coast past Chickerell and to Weymouth. Behind Chesil Beach is the Fleet, and that is our example of a lagoon. Right, which one's the odd one out then? You've got arch, spit, stack and wave cut platform. 5 seconds, make your decision, and I want to know why. Let's justify that answer. 3, 2, 1. It is spit. And tell me why. Because spit is the only depositional landform. Arch, stack and wave cut platform are all erosional landforms. Which of these is the example of a spit? Studland, Sandbanks, Chesil Beach or Swanage Bay? Jot down your answer. Did you get it? It was sandbanks bit. It's task time. I'm going to ask you now to draw a table and categorise Dorset's landform. Try and use a ruler to make sure this table is super neat. The landforms that you need to include are shown in white. Can I just draw your attention to the capital letters? Please make sure you copy those really carefully. So where they're names, they get a capital letter. 4 of those have got a star. And where they've got a star, I'd like you to do a little bit extra. I'd like you to name the landform. So I'm going to give you 1 to start you off. Durdledore, it's got a star, so we need to name the landform, is an arch. And an arch is an erosional landform. Pause the video, off you go. Let's check how you've got on. Pause the video so you've got time to check your answers and have a look at those capital letters. Let's tackle grid references now because we see them in those exams, and it's really important that we practice these so we become confident because they're easy marks for us to get. We're going to be looking at the 6-figure grid reference for Ballard Point. So over here is Ballard Point, but we're looking for this corner of the land. We're not looking for the word, so be really careful about that. We're going to go along the corridor first. Along the corridor, we get to 03. The numbers are hidden on the map here. So 03, 04. Now we've got to the right line for a 4-figure, but we want to get the 6-figure. And to do that, we split each square into 10 small sections. So this is on line 04. So it's 040, 041, 042, 043, 044, 045. And 5 is always at the middle, so you can estimate that really easily. 6, 7, 8, 9, and then we're back to the line again. So this is actually 050. We're looking for Ballard Point though, so how many along? It is 8 little squares along, so 048. Next we go up the stairs. 79, 80, 81. So our 4-figure grid reference would have been 0481. But again, we want to count how many little squares up. Here's Ballard Point, so we go along here, and it is 2 little squares up. So Ballard Point is located at 048812. And remember, you can pause the video and spend as long as you like looking at this. Let's test you. It's your turn now. So what is the 6-figure grid reference for Old Harry? Pause it until you've made your decision. Take your time, run your finger along the screen, okay, whatever you need to do to make sure you get it right, okay? But you can do this. Right, did you get B? 03, 04, 05. How many little squares along? Old Harry, here it is, halfway, so 5. Then we're going up the stairs. 79, 80, 81, 82. How many little squares up? There we are, again. Round halfway, so the answer is B, 055825. Another thing examiners like asking us is to work out distance on a map. To do this, we need to know that 1 blue square on an Ordnance Survey map is always 1 kilometre. We want to try and get from Old Harry, so here it is, sit up in the top corner, the stack, down to Ballard Point, and to find out how far that is. The first thing you would do is line up a bit of scrap paper between Old Harry and Ballard Point. So if this is my piece of paper, you can see where I've put Old Harry on the top corner, and I've lined it up along the coastline so it's in line with Ballard Point. You then need to mark the paper. So we're going to mark so we know the distance by a piece of paper. Then we're going to hold that paper against this key, or you can hold it against any of these squares because we know that that distance now is 1 kilometre. Here's my piece of paper against the key. So the distance was from the corner to here. So I've measured that that section there is 1 kilometre, but we've still got this extra bit. And I think if I estimate, that's about 0.25. So the answer is that Old Harry is 1.25 kilometres away from Ballard Point. Now you're experts on the Dorset coastline, I want you to tackle this question. Explain how erosional landforms have been created on a section of UK coast that you have studied. It's worth 4 marks. To be successful in this, I would like you to mention real place names. I want you to make sure you include correct sequence, and I want you to include processes like abrasion or longshore drift or deposition or hydraulic action. But I'm going to help you out. I've just changed that question to say depositional landform so you can see what it should look like. Chesil Beach, so I've named my landform, is a depositional landform on the Dorset coast. The bar formed due to the prevailing wind blowing waves up the beach as swash. They then retreat as backwash. These waves carry sediment with them as longshore drift. At a change in direction of the coastline, this continues, and over time deposition builds up as a spit. Gradually this spit grew, and when it rejoined land it became a bar. The fleet is the lagoon that has formed behind. So in here I've mentioned 2 places, the Fleet and Chesil Beach. I've done it as a step by step, and I've got my process words in pink. But you're doing erosional landforms, so let me help you out a step further. I'm going to give you some information about Old Harry Rocks, which is a stack. Old Harry Rocks is situated on this area of chalk rock. This bit of rock that sticks out is called the foreland. It's a headland on this chalk rock, and Old Harry is just in the sea off there. Stacks form when destructive waves erode a headland through processes like abrasion. There will be faults in that rock, and hydraulic action will start to cause these cracks to enlarge. They get larger and larger until they form a cave. The waves are going to erode the back of that cave through abrasion, and the cave will get deeper and deeper until eventually it will wear through the headland, creating an arch. The arch gets eroded at the base by the waves, but at the top, the rock gets weathered. It's not supported now, so gravity will eventually cause the top of that arch to fall into the sea. When it does, it leaves an isolated pillar of rock, and this is called a stack. Explain how erosional landforms have been created on a section of UK coastline you have studied. I've given you a writing frame there to help you. You can use it or you can do your own thing. Good luck, rejoin me, and I can't wait to see how you've got on. Let's have a look at your writing. Old Harry Rocks is an erosional landform on a discordant section of the Dorset coast. It has formed on chalk, which is resistant to erosion. So we've got some good keywords in there. I think discordant might be one you could add in. The stack formed due to the destructive waves eroding the foreland, which is the headland, through processes like abrasion. Hydraulic action causes faults in the rock to widen, eventually creating caves. Abrasion erodes the back of these caves, deepening them until they break through the headland, creating an arch. Over time, the arch is weathered, and as it is unsupported, gravity will cause it to eventually collapse. The isolated pillar of rock remaining, Old Harry, is the stack. I would take a moment now to pause it, make any changes that I need to, add any of those words, especially if they're in pink or purple, into your writing. Well, we've certainly covered a lot of ground today. We've looked at the Dorset coastline and its stunning erosional and depositional landforms. But we need to make sure that we are as resistant as Dorset's limestone and chalk headlands to forgetting about our learning. And to help us do that, we need to recap it frequently. So can you click on the next slide for me as soon as I'm done, and I would like you to show me what you've learned in the quiz. Thanks very much for your time today. I don't want you to leave your learning as isolated as poor old Harry, so please pop back soon where we're going to start to look at how we're going to manage our coastlines. Have a great day today, everyone.